today's video, we'll be building a server to use my CCTV NVR running Frigate. When I first installed my CCTV system a few months ago, I temporarily set up Frigate on a Dell Optiplex 5070 Micro, and it's been working well, although now that I have all my cameras up and running, the 1TB hard drive just doesn't have enough capacity to store recordings for as long as I need to. Unfortunately, since it's a small form factor machine, it only supports a single 2.5-inch hard drive up to 9.5mm thick, which limits me to drives up to 2TB, which just isn't going to be enough. Of course, I could possibly bodge something to make a thicker drive fit, but I'd rather just build a nice machine that's purpose-built to work as an NVR, and I can always repurpose that Optiplex as a VM host or something like that in the future. So now, let's start by taking a look at the hardware we'll be using, and then we'll get on with the build. So first up, here we have the case, and this is a bit of a challenge to find since my case requirements were a bit unusual. First of all, I obviously wanted a rack mount case, and I wanted something that was 2U in height. Building on a 1U case generally just gets really awkward, so I tried to avoid it where possible. You need ultra low profile coolers, even a standard ATX I/O shield is too tall, so you need to start cutting that down, and even then you can find some motherboards that have components that are just too tall for a 1U case, so it's just not worth the hassle in my opinion, unless you're specifically using a server motherboard that was designed for it. So, 2U case. Nothing too rare so far, but then we have my next requirement that significantly limited my choices. I wanted a 2U case with 4 hot swap drive bays, and not a minimum of 4, I wanted exactly 4. But why? Well, my plan for this machine is to use a standard PC motherboard, which helps keep the power consumption low and allows me to use the Intel iGPU. However, most consumer motherboards only come with 4 SATA ports. If I'd gone with the more common 2U cases that have either 8 or 12 drive bays, I'd then either have to deal with drive bays that weren't connected, which I just know would irritate me, or I'd need to install an additional SATA controller or HBA card, which would increase the power consumption. Thankfully, I came across this case from Innovision on AliExpress, and the model number is NF257H, and this meets my requirements perfectly. It's 2U high, has 4 hot swap drive bays, and has plenty of space to work inside. And I'll leave links to it in the description and in a pinned comment, along with links to all the other parts we'll be using in this build. The only downside being that it wasn't particularly cheap. The case itself cost £82 on its own, but I ended up paying £121 to get the additional rack rails included, which you really do need for a case this deep. Now, that's actually pretty good value for a case like this, but of course the downside is that the cost to ship it to the UK from China was an eye-watering £112. That said, when you factor in the cost of shipping as if it's just part of the cost of the case, just over £230 for a decent rack case with hot swap bays isn't completely unreasonable, but if I was happy with 8 or 12 drive bays, there would definitely be much cheaper options available from a UK supplier. In addition to the case, I also picked up the optional lockable front bezel. This was only around £20 and was really just more for aesthetics than anything, since I want this to look more like an NVR appliance and it's already being installed in a locked rack. Which is good, since it turned out the bezel is actually made of relatively soft plastic. Of course, a lock like this isn't really going to stop anyone anyway, but it does feel like you could very much just pull this off the front of the case without much effort. It's not particularly secure. That said, these bezels are much more designed to stop casual tampering if the machine was to be installed in somewhere like an office or shared co-location rack, and since I only really bought it for the looks, it'll be fine. I'll probably end up printing off a Frigate logo and put it on the front panel here, just to give it more of that sort of appliance look. Taking a closer look at the case, on the front we have 4 hot swap SATA drive bays, with all the caddies included, and they all feel pretty decent quality, and it looks like these have some sort of screwless plugs to let you hold a drive in without screws. That's pretty nice. Then next to that we have a power button, a reset button, a couple of USB ports, and then a couple of LEDs for hard drive activity and a couple for network activity. Unfortunately, I won't be able to use the network activity LEDs with a consumer motherboard, so I'll just have to deal with those not working. We can then remove the top of the case just by using these 2 buttons here. It also comes with a bunch of screws installed around the side as well, but you don't necessarily need those. The top stays on just fine using the clips. Taking a look inside the case, down the front we can see we have our 2 hot swap bays. We have 2 separate cages, each with their own backplane, which takes power from a single Molex connector and then has a pair of SATA connectors for data. They then also have a pair of 4-pin fan headers. I can't see how they've been doing any sort of fans monitoring or speed control with the board, so I suspect they'll probably just work like 2-pin fans, but they're still nice to have. Then next to these, we also have a pair of internal 2.5-inch bays, and behind these we have 3 pre-installed fans. Now, these aren't going to be anything particularly special, but they have installed them on anti-vibration mounts, which is nice, and they should hopefully provide plenty of airflow through the case to keep the hard drives cool. It's a bit annoying that they're using Molex connectors for the fans, especially since there's fan headers on the backplanes literally next to them, but it'll work fine. That said, I might consider swapping these out for 3-pin fans so that I can connect them to the backplane, or I might actually have some fan connectors sitting around where I could just cut the Molex off and crimp some fan connectors on. We'll see what I end up doing later in the video. Then behind the fan wall, we have the motherboard tray, which can take up to standard ATX boards, and then a set of 3 full-height expansion slots. Of course, these are horizontal slots, so you need some sort of riser to use them. There's a couple of them pictured on the AliExpress page alongside the case, but I couldn't find them on the store, so you probably need to contact the seller. Or alternatively, I suppose you could just use one of those flexible PCI Express riser cables. Then finally inside the case, we have the space for the power supply, and this is where things get a little bit more awkward, because with 2U cases, there's a couple of different power supply options. On cases that only support micro ATX motherboards, you can usually use a standard ATX power supply. The only requirement generally being that you'd want to use one that has a rear 80mm fan instead of a top-mounted 120mm one. However, on cases like this that support full-size ATX motherboards, an ATX power supply would be too big, meaning that these cases usually use a special form factor of power supply, generally referred to as a 2U power supply, and these aren't particularly common or cheap. Now, you could potentially find or make a bracket that would let you adapt a smaller power supply such as TFX to fit into this space, but I ended up picking up a proper 2U power supply for this build. And in particular, I went for a Seasonic SS400 H2U. It was just the most affordable and lowest wattage one I could find, and since I wanted to keep it as efficient as possible, using a super high wattage one designed for a dual CPU server would have just been silly. As you can see, the power supply fits in the case perfectly fine. We can just slide it in there like that, and yeah, it fits fine. Now, there is this extra bracket here to secure the rear of the PSU, however it doesn't seem to fit my power supply, and then the bracket that my power supply included doesn't seem to line up with any of the holes in the case. So I'll just try using the rear screws, which I'm sure will be absolutely fine, but if I'm worried I could always drill a couple of additional holes to secure this bracket into the case. Then looking at the back of the power supply, it's sort of modular in that the cables are all detachable, but it's more of an installation aid than anything else, since realistically you need all 3 cables to do anything, since one of the cables has the 24-pin ATX connector, the other cable has all the 12-volt stuff, so your EPS, PCI Express, an additional 8-pin EPS for some dual CPU motherboards, and then the final cable has all the Molex and SATA power cables. The only other thing worth mentioning when it comes to power supplies in this case is the other option you have, compared to using one of those 2U power supplies, is using these 2 brackets that the case comes with, which lets you install a redundant 2U power supply. So they're sometimes referred to as CRPS power supplies, and basically it's an outer cage that takes 2 separate small redundant power supplies. So you can install that instead if you wanted redundant power supplies, but for my setup here, that would just be completely unnecessary. But at least you have that option if you needed it. So, that was a look at the case and power supply. Now let's run through the rest of the parts we'll be using. So first up, we have the motherboard and CPU, and I've gone for an Intel Core i3-14100 and an MSI H610M-G DDR4. In terms of the CPU, I basically just wanted something that was as close to or better than the CPU in my current NVR. The current NVR has an i5-9500T, so a current gen i3-14100 seemed like a reasonable choice. In particular, I absolutely need the iGPU for this build, hence going for the full-blown 14100 and not the 14100F. Then for the motherboard, I went for this one purely because it was the cheapest option that met my requirements, which were something that would of course support the CPU I've gone for, and I needed something with an E-key M.2 slot for the Coral TPU module I'll be using to accelerate object recognition. This particular motherboard is available in a few different versions, one with an Intel NIC and the other with a Realtek one. I opted to pay a little bit more for the Intel NIC model, just since I tend to trust them a bit more in terms of reliability and stability. It's also available in both DDR4 and DDR5 versions, but the DDR4 model was cheaper, along with allowing me to use cheaper DDR4 RAM, so I went for that. This isn't the sort of build where I need to squeeze every single bit of performance out of the parts, it just needs to basically do the functions that I need it for. As for the rest of the parts, we have the RAM, where I've gone for 16GB of DDR4. This is absolutely excessive, but realistically nowadays it was actually cheaper to get this than a pair of 4GB sticks. Then storage wise, for the boot drive I've gone for the 256GB Patriot P300. Why? Because it was the cheapest drive from a reputable brand I could find at the time of purchasing. All this needs to do is boot and run the OS, so it's really not particularly important. Then for storing recorded footage, we'll be using a pair of 8TB Western Digital purple hard drives. I'll run these in RAID 1 to give a total of 8TB of usable space, with redundancy to handle a single drive failing. This should give me way more than enough capacity to hit my target of at least 2 weeks of continuous recordings, but I could always expand it in the future by adding in a couple of extra drives. Then finally, to connect the drives up, I'll be using this multi-core SATA cable. It's nothing special, it's basically just 4 separate numbered SATA cables in a single outer braid. But I really like using these for systems like this versus running a lot of separate, thick SATA cables. You can also get these in variants with even more internal cables, so they're definitely worth checking out if you're building something like this, since they're so much neater to manage than your usual flat SATA cables. And then the final part we have is this Coral TPU. This is an AI accelerator chip developed by Google that Frigate will use to accelerate object recognition. The way it works is that Frigate detects areas of an image that's recently changed, crops it out and scales it down to a lower resolution, and then passes it onto this chip to perform object recognition. This massively reduces CPU load and makes object detection super quick. And while this may sound fancy, these things only cost around £25. The version I have here is an M.2 version that works on an A+ E key slot, which this motherboard has since it's generally used for Wi-Fi cards. However, they also do a bunch of other versions for different keys of M.2 slots, mini PCIe slots, and even do versions that just connect over USB. So, that was a look at all the hardware we'll be using. Now let's start building this thing. Okay, so now let's start putting this thing together. I was toying with not filming it or maybe doing a time lapse or something, but I thought I would just do a bit of a rambly, unscripted build just because people might find it as interesting as like background noise or whatever. So I'll put it together, cut out through any really boring bits, and feel free to skip ahead if any of this isn't really interesting to you. But let's put this together. So we'll start putting the CPU in. It's actually been a long time since I've built anything, especially since I've built anything where I actually had to install the CPU. I think the last build I did was just like a integrated N100 motherboard. So, I mean, I'm sure I won't forget any of it, but yep, time to put this together. In fact, last time I built something with an Intel chip, the socket was definitely a lot more square than these new ones. Obviously, I think it was maybe 1150 something, whereas it's now socket 1700. But yep, let's get the CPU installed so we can put that in there like that. And then I'll look forward to when I inevitably do something that's apparently the biggest crime ever, even though it's probably not, and upset a bunch of people. But yep, that's the CPU now installed like that. So next up we'll chuck the RAM in. So let's 2 sticks of RAM. We've only got 2 slots in this motherboard. I think those 2 clips are fixed by the looks of it. So we'll maybe rotate it around so I can figure out what I'm doing here. So yep, now we can get the RAM and slot that down. This is one of those things that it ends up a lot fiddlier to do because I'm recording it, and then people always get really upset like, oh, why did you do that way? Why did you struggle to put that little piece in? It's like, well, because when you've got a camera next to you, a microphone above you, you're trying to keep everything in shot, not knock everything over, not move off axis from the microphone. It does get a little bit tricky to do. Anyway, I'm just ranting, but yeah, get the RAM in. Again, completely excessive amount of RAM. Probably doesn't even need to be dual channel really, but it's so cheap to get 16 gigs of dual channel DDR4 nowadays. It's just, there's no point in not getting it really. And obviously it means if I ever repurpose this build in the future or need the RAM for something else, I've got decent RAM here. So yep, that's the RAM installed. So next we'll put the SSD in. Interestingly, for the SSD, it comes with this little weird screw. I think they call it a M.2 locker. And it's basically a little screw thread on the bottom and then a little lever you can flick round. So I presume this makes it tool-free to swap out the SSD once you've installed this. So I'll just need to put that in. That'll require a screwdriver to install. You could probably install it without one, but we'd rather it was tight and didn't come loose for obvious reasons. So that's in there like that. And then I assume I just slot the SSD in and then flip that bit plastic round. Okay, so we have the SSD here, so the lock's in place. So in theory, we just slot the SSD in like that, fold it down, and then this just slides over it. Okay, I don't actually hate that. Now I figured it out. It was a little bit fiddly, but that's actually quite nice. So yeah, that's in there. And the final component we need to install on the motherboard is the Coral TPU module, which unfortunately isn't screwless, but it'll go into this M.2 slot that's labelled for Wi-Fi because it's the same keying that you'd use for Wi-Fi. I'm pretty sure this key of M.2 slot contains both USB and PCI Express lanes, but this Coral TPU specifically does use PCI Express. And that's just important to bear in mind because I think on Linux, if I remember correctly from when I set this up before, the USB version is supported natively, whereas the PCI Express version does need you to install some sort of kernel module to support it. Once you do that, it works absolutely fine. It's just worth bearing that in mind, that if it doesn't show up immediately, don't panic. So that's the Coral TPU installed, and that's the rest of the motherboard all built. So now we can get the case out and start putting everything in it. Actually, no, we're not done. Completely forgot to put the CPU cooler on. That would have been exciting if I built it and completely forgot this. So we're just going with the Intel stock cooler. It'll be absolutely fine. Kind of interesting though with this, like I've never not seen one of these in a long time, that they have now tried to like make it look more beefy by like putting these fins around the side, but they're just plastic, so the actual only fins are just on the bottom. I mean, whatever, it will work absolutely fine for this machine. It really does not need really anything particularly special at all, but I just thought that was quite funny. So put this on, nice and easy to install at least. So yep, just click the individual little push pins down. There we go, and the final one. There, and that's now installed. So yep, and with that, the motherboard's now built, so we can just plug the CPU fan in. So now, let's get the case out, get it all set up, and get the machine built. Okay, so now let's get the motherboard installed. So we'll start off by putting in the I/O shield. You'll see I've already put the standoffs in just because that's a bit of a fiddly thing to do on camera that would just take ages. And it's actually nice, these are those nice standoffs that kind of have a bit for a flathead screw in the top, so you can install them without needing a kind of really small hex socket or something like that. So they are quite nice standoffs, which is good. The case seems reasonable quality. I mean, it's definitely a standard rack mount case in that it's quite sharp and metal, and you wouldn't want to, run your hand against it, but that's fairly standard for a lot of rack mount cases. They're not like consumer PC cases that are generally a lot more finished, but it seems pretty good quality, feels pretty rugged, robust. And then this bar here, which is more for holding a PCIe riser card, does really help the rigidity, which is good. But yep, I/O shield's now in, so we can now get the motherboard in. Also, I just noticed with the motherboard, just laughing at myself, I put it all in and then realised the cable was I should have really oriented the cooler differently, so the cable didn't have this big loop in it. And I realised that the reason I oriented the cooler that way was so I had the Intel logo the right way up, even though it's on the bit that spins. So anyway, I'm not going to redo it just because it's a minor cable thing and I would need to replace the thermal paste and stuff like that, but just was laughing at me trying to be nice and have the Intel logo the right way up, and then only afterwards realised it was on the bit that spins. I'm not very smart sometimes. But yep, let's get the motherboard installed. So we'll get that in there. Be extra careful just because I always end up catching on these little metal tags and I don't want to short anything out. So, and again, it's one of those things that if you're not doing it on camera is significantly easier. But I film it for some reason. Yep, that looks like the motherboard is now in. And yep, that all now looks good. So let's just screw this in. So really need to get a magnetic screwdriver for this sort of thing because it's fiddly when I don't have magnetic ones, but I do have one, I just can't be bothered going getting it. So this will do. So let's get this all screwed in. And then we can do the more, interesting bits. I don't know. Let's get the motherboard in and then we'll do the rest of it. Okay, so I've now installed all the SATA cables just to get them out of the way. So I've got them all connected into each of the two drive caddies, one connector per drive, and then I snake round here and plug into the motherboard. And then I managed to loop the extra slack up between the cages here and then up between these cages here, and cable tie it all in place, so it's all pretty neat and secure. The only difficulty I had is that because these SATA connectors have a clip on top, what I first did is I installed the ones on the bottom of the motherboard first, and then tried to plug the top ones in, and they were catching on the clip of the bottom connectors. So all I had to do was install the top two first, and then install the bottom two, and then it worked fine. So just a bit fiddly there, but that's now all installed, and that is so much neater than if you had a bunch of separate SATA cables. I maybe should have gone for the shorter version of this cable. There's quite a lot of slack in here, but I'm sure it'll work fine. If I do ever have any issues, I can always swap it out for a shorter one. But yep, that should work well. So now, let's get the power supply installed. So as mentioned earlier, here we have the power supply, and this will install here and secure to the back of the case with 3 separate screws. Now this case also has this additional bracket here for securing the back of the power supply, but that unfortunately doesn't fit my particular power supply. Similarly, my power supply came with an additional bracket in the box that screws onto the back of the power supply like this, and would also let you secure this to the case. But unfortunately, none of the screw holes on this line up with anything useful on my case. But what I'll do is I'll leave the bracket installed here, and I'll install the bracket on the power supply just so that I have both brackets and don't lose them. If I took them off and stored them separately, I would just lose them. So I'll keep both brackets installed, but I'll just only be securing it with the rear 3 screws, which I'm sure will be absolutely fine. If there's any issues though, I could always drill a couple of holes in the bottom of the case and screw through into this bracket here. So yep, let's get that installed. So we'll slot that down in there like that, get it all screwed in, get the cables all connected up. I'll do all that off camera because that just gets fiddly and messy, and we'll look at it when it's done. Okay, so that's power supply now installed. It's all completely secure with those 3 screws at the back. But what I've also done down here is I worked out that you can, what I did is I've installed with the bracket that came with my power supply on the power supply, and then the bracket that came with the case, I've slid over that bracket and screwed it down. It's not how it's meant to work, but that also helps secure that at the back. It just stops it lifting up. Again, it was completely fine without those rear brackets. It worked completely fine with just the 3 screws here, but did that there just because I may as well. So yep, that's power supply now installed. So now let's get it all cabled up. And there we go, that's it all now cabled up. So I've got the power supply installed, got all the cables into everything, got the front panel connected up as well. Obviously, you can't really neatly cable manage a rack mount case any really much more than this. There's just no space to hide cables. So the best you can really do is try and keep them secure so they're all tied up nice and securely so they're not going to move around, not get in the way of fans, block airflow, things like that. And if you can manage that, that's all you really need to do. So yeah, pretty happy with how it's all turned out. So that's all connected up absolutely fine there. The only thing I don't really like is the fans obviously being Molex. This big flappy Molex stack thing just looks a bit rubbish. Ultimately, this would be absolutely fine, and I could just use this, but I found that I had some spare connectors. These are JYK connectors, also often referred to as KK connectors. One of those things where I think Molex owns the name KK and other brands kind of change it. So JYK, basically fan headers. So I've got these and I can crimp them on. So what I'm probably going to do is just cut these Molex connectors off, crimp some of these on, and then I can plug them straight into the back plane here, which will just be a lot neater. So I'll go away and do that now, and we'll come back and take a look at the finished system. There we go, that's so much better. So I've now crimped these 3-pin fan connectors onto each of the fans, so I've now got them there, so they're now plugged directly into the back plane, as you can see with those 3 connectors down there. And it just means that we don't have that sort of horrible snake of Molexes all stacked up over here. It's just much neater. Bit unnecessary, but just I much prefer that, how all that looks. So yeah, now let's get this up on the case, get the hard drives in, and we can get this thing installed. Okay, so now let's get the hard drives installed. So I've already put one in, so all you do is pop the caddy out, we get the hard drive positioned correctly to go in, and they are toolless, so if I just put that in there, it literally just clicks in, and that is actually really secure. I don't know why like more sort of high-end servers don't do this. This is so much easier than sitting on the floor of a data center trying to fiddle about with tiny little screws, trying not to drop them down a vent in the floor. But yep, that's now installed. But if you did want to install 2.5-inch drives, you can also just install them using 4 screws here, so that is also an option. But yep, now that's installed, we can just slot that into the case and lock it in place. Yep, that's installed. So with all that done, that's the build as far as I can think should be complete. So now let's get this connected up and see if it works. Okay, so now we have the server all connected up, so we've got a keyboard connected to it here, connected to power, and then it's connected to HDMI through the HDMI port that runs through the wall into the TV. So now let's turn it on and see if it works. So, hit the power button. Now, it's definitely not particularly quiet because those case fans that came with the case aren't speed controlled in any way, but it'll be fine because it'll be outside in the comms rack in my garage. But if you're having this inside, you definitely want to replace those fans with something a lot quieter. But let's see if we get anything on the screen. Yep, so that's us now automatically loading into the BIOS. Also, while it was booting up there, or loading into BIOS anyway, I saw the hard drive LEDs flash on each of the discs, so the drive caddy LEDs do actually work, which is nice. And we're in, so we're in the BIOS, we see we've got the CPU detected, all the RAM's detected. Somewhere in here we'll find that the storage is detected. Yep, so there we've got our 2 Western Digital Purple 8TB drives, and then we've also got the Patriot SSD there as well. So, yep, that all seems to be working. Also, weirdly on this motherboard, the SATA ports are numbered 5 to 8, which they're also numbered 5 to 8 on the motherboard itself, but there's no SATA ports 1 to 4. I suppose one might be an M.2 slot, maybe 2 of them could be M.2 slots, but there's not that many. Anyway, rambling. So, that's up and running. So what I'll now do is I'll go away, get Linux installed, get Frigate installed on that, and we'll come back and see, hopefully, a fully functioning NVR. And there we have it, it's now working. So we've got it all booted up, I've got Frigate installed. All I did is install it, then installed Debian bare metal on the machine, set up Docker, and then Frigate is deployed through Docker. And it works brilliantly. Then for the drive configuration, I've set the 2 8TB drives up in a RAID 1 mirror, just using Linux built-in software RAID, so MDADM. So there's a software RAID mirror, and they're working great. As you can see, I've then got connected to Frigate from a separate PC through the web interface. Works perfectly. Then the other thing I've done is, if you look at the front of the bezel, I then printed off a Frigate logo and put it on there. So again, just a bit of eye candy, makes it really look like a sort of proper official appliance when that's on, which looks really cool. And to do that, all it is I printed it off on my Brother label printer. So I use desktop software, print off the label, and it means that because it's printed on a label printer, not like a normal just office printer, it's a proper laminated label. It looks really, really good. So yeah, really happy with how that's turned out. So yep, that's it all up and running. The only other thing worth mentioning is the power consumption. At idle, with no software running on it, this draws round about 42 watts, which isn't super low. You could definitely get lower if you kind of went with a small form factor PC like I was using before, but it's not too bad. Realistically, about half of that power consumption is just the 2 hard drives and the 3 big case fans. If you take those out, it's a lot lower. It's closer to about 20 watts, if not a bit lower than that. So a lot of that power consumption is coming from the fans and the hard drives. If I wanted to lower it in that with those two areas, I could definitely go with lower power fans, and these Western Digital Purple Pro hard drives are 7200 RPM, so I could definitely save a fair bit of power with 5400 RPM drives. But realistically, the amount of money I save in power is not going to justify the cost of buying new fans or replacing these hard drives. These hard drives I had sitting around spare, so it made a lot of sense to use them for this project. And realistically, 42 watts isn't a problem at all. Now, I suspect the power consumption might be a little bit higher now that Frigate's running. Currently, it's drawing about 56 watts from the wall, but that's also because currently the RAID array is still doing its initial sort of sync, because I've just created the RAID array recently, and that's going to take probably about 10 hours to complete. So that power consumption is probably also affected by that. So 56 watts currently with everything running, but I suspect that will come down a little bit once the RAID array finishes syncing. But yep, that's it all up and running. So all that's left to do now is run down to the garage, get this installed in the rack, and then wrap this up. Okay, so now let's get this installed in the rack. So I've already installed two rails here and here. They're relatively easy to install. They're not nice toolless rails, unfortunately. They are just threaded holes, but they do work. The only thing to bear in mind is these rails are the ones where the thread is built into the rail and then you screw through the front directly into the rail. They work absolutely fine on a square holed rack like this, but they don't really work properly if you've got an more sort of old-fashioned or telco style rack that's got pre-threaded holes. Just something to watch out for. But works absolutely fine here, so that's installed there. So we've got a rail on each side. And since they're nice, proper locking sliding rails, we can slide the inner rail out like that. That then locks in place in this sort of extended position, and then we can find the switch on the side, pull that in, and that will then let me take the inner rail out. So what I need to do is take the other inner rail out, get the inner rails installed in the server, and we get it slid into the rack. So there we go, that's the incredibly greasy rails installed in the server. So they just clip on toollessly, which is nice. Little clip there to release it. You could put a screw through if you wanted to secure it, but this clip at the back holds it completely fine, so I'm not going to bother with that. So yep, that's it ready to go in the rack. So now let's slide this in and hope it all fits and works. Okay, so one very minor hiccup that I've been able to figure out. When I initially installed the rails, I used the screws they came with, which are these, and it might be quite hard to make out, but they've got a sort of very slight inner lip, so there's the outer head of the screw, then they come up and there's a small additional inner lip, and the idea behind that seems to be that when you put that in a square hole in the rack, it very much centres it in the hole and keeps it centred. But the problem with that is that there's absolutely no play in it whatsoever. And you think about it, even with a cage nut, you do actually get quite a bit of play, sort of side to side as you put the screw in to let you kind of move things around. So when I used the original screws, what happened is the rails were just maybe a millimetre each, if that, too far towards the centre of the rack. And then when I tried to install the server, it was very, very stiff, and the problem is this rack's on wheels, so you're pushing the server and the rack's wheeling around the room. And then when I finally got it all the way in, I couldn't get it maybe pushed in the final centimetre. It was just so tight, it was just a little bit annoying. So it's a bit weird with these screws that there's just no play, and on some racks it's probably absolutely fine. On other racks like this one, it's just that little bit too tight. Because that's the problem with rack mount gear, is that obviously it is standardised to like 19-inch racks, things like that, but there's always slight tolerance differences between racks and different bits of kit, and if you've got stuff that doesn't have any wiggle room, you can run into issues like this. So as a solution to that, all I ended up doing was finding these other screws here that don't have that lip, but they've still got a pretty big hole that fills over the hole in the rack. Put them in, and that, because they don't have that middle bit, they let me sort of slide it over a little bit, tighten them up, and now that's completely flush with the side of the rack. And then around the back of the rack, very similar idea. I only had 4 of those screws I had at the front, so all I did at the back is I just used a normal M5 screw and then just put a washer on just to hold it. So that should all be fine now, so now we can finally get that server installed. And yet, with that change, it now works absolutely fine. So that's on there, slide it back. And then the only other thing I've done is I've put a cage nut in the top position of each of the top U, and that just means that once it's pushed back, I can then put a single screw through the top of each side of the server, just to secure it in place so it doesn't pull forwards. Lots of rack mount kit with rails will have some sort of clip mechanism or whatever. This doesn't have that. It has a clip to stop you pulling it all the way out, so when you pull it to here, it stops, and you have to then release the clip on the side, but I just didn't want it to slide forward, so we can hopefully release the clips on each side, which I shouldn't have done when I had the camera in my hand. There we go. And then now, that should just slide back. Yep, there we go. And now that is actually slid all the way in. So all I need to do is put a screw in each side, get it all connected up at the back, and fire it up. And with that, it's all installed and up and running. And I don't know about you, but I think that looks really smart with that bezel. So yep, it's working. So hopefully you found this video interesting or potentially useful if you're planning on building some sort of Frigate NVR, or if just really any sort of 2U custom built server with regular desktop grade hardware. So yeah, I hope you found it interesting or useful. But all I have to say now is thank you very much for watching, and if you're interested in buying any of the parts I used for this build, I'll leave links in the video description and in a pinned comment.